Okay, guys, last video of chapter 11. Like I mentioned earlier, intermolecular forces play a really huge role in a bunch of properties of liquids, specifically physical properties of liquids. The properties that we're going to focus on are these four. Vapor pressure, you've heard of, you know what vapor pressure is. Boiling point, you know what boiling point is, and you know how these two guys are related. A substance that has a really high vapor pressure has a low boiling point. A substance that has a very low vapor pressure has a very high boiling point, okay? And then surface tension and viscosity. So let's first focus on vapor pressure and boiling point. Okay, if you have a molecule that has a lot of intermolecular forces, it has London forces, dipole-dipole, and hydrogen bonds, especially those hydrogen bonds are really strong. If you have something that has a lot of these intermolecular forces, it's going to end up having a very low vapor pressure. It's not going to become a vapor very easily at all. And if it has a very low vapor pressure, it's going to have a very high boiling point. So here it is. High intermolecular forces is going to cause a very low vapor pressure and a very and if you have very low intermolecular forces, you're going to have a low boiling point. But if you have high intermolecular forces, you're going to have a high boiling point. This one, high intermolecular forces will give you a low vapor pressure and hold on a second. Yeah. Oh, this is, I should have put this up here, guys. Sorry about that. Anyway, this thing over here. Yeah, it's fine here. This is fine. Okay, these are the intermolecular forces relating to boiling point. This one over here, if you have low intermolecular forces, you're going to have a high vapor pressure. Okay, so these are the two vapor pressure things, and these are the two boiling point. Again, don't memorize this stuff, understand it. It makes sense. The more attractions between molecules, the less they're going to want to go into the vapor phase, leave the liquid phase, and go to the vapor phase. The more energy you're going to have to put in to force them to separate and become vapor. Because once they become gas, the attractions are minimal, remember? So that was one of the kinetic molecular theory, is that you don't have a lot of attractions between these gas molecules. So if you have a lot of attractions in the liquid, it's going to be really hard to turn them into a gas. Okay, so lots of attractions means very low vapor pressure, very high boiling point. Not a lot of attractions, like something that just has London forces, not dipole-dipole and hydrogen bonds, is going to have a really high vapor pressure. It's going to be super volatile. It's going to end up having a very low boiling point. Okay, what are the other two? Surface tension. The word surface tension, this is basically the energy needed to increase the surface area of a liquid. You know how when you drop liquid on the table, some liquids just stay as a little droplet and others just spread very easily? The ones that spread very easily have a very low surface tension. They spread really easily. The ones that stay as a droplet have a very high surface tension. And that high surface tension is related to high intermolecular forces. So the more the intermolecular forces, the more it's going to stay as a droplet because they're very attracted to each other. The less the intermolecular forces, the easier it is for it to spread on your table. Okay? Next one is viscosity. What does viscosity mean? That means resistance to flow. Just think of something going through a pipe. One is going really easily and one is having a really hard time going through the pipe. So when something is viscous, it's viscous because there are a lot of intermolecular forces. So again, the molecules are so attracted to each other, they don't flow very easily. Okay? So something that has a lot of hydrogen bonds, dipole-dipole, London forces, is going to have a high viscosity. Something that has a lot of hydrogen bonds, lots of dipole-dipole, lots of London forces, is going to have a high surface tension. It will also have a low vapor pressure and a high boiling point. Okay? That's how we tie it all in. All right, so I'm going to put a couple of things on the board and see what you guys have learned from all of this. Right? So let's say I have these molecules. I have BCl3 and PCl3. Let's take a look, guys. I don't know if you remember this from chapter 9 and 10. Okay, so this is boron trichloride. And this is phosphorus trichloride. Okay? Let's take a look at those two molecules. Which one is going to have a higher vapor pressure? Okay, higher vapor pressure means it doesn't have a lot of intermolecular forces. Remember, it can become a vapor very easily. Higher vapor pressure. So which one's going to have a higher vapor pressure? Well, let's take a look. What type of intermolecular forces can this do? Well, this obviously can't do hydrogen bond. Is it polar or nonpolar? Remember how this is completely symmetrical, so this is nonpolar. So the only thing it can do is London force. Okay. What about this one? No hydrogen bonds, but it's polar. How do I know it's polar? Because of this lone pair here. So it can do dipole-dipole and London force. So what was the question? Which one's going to have a higher vapor pressure? That means it can become a vapor really easily. This guy, because all it can do is London force. Okay? The less the intermolecular forces, the higher the vapor pressure. Okay, which one is more viscous of the two? This one is more viscous because it has more intermolecular forces. Which one's going to have a higher boiling point? What do you think? Higher boiling point, this guy. Which one's going to have more surface tension? This guy. Okay? All right, let's do another one. The difference between water, H2O, and H2S. All right. They look similar, right? Both bent angular. All right, which one's going to have a higher vapor pressure? Again, let's take a look at what are the intermolecular forces. Obviously, this can do hydrogen bond. Hydrogen bond always exists. The molecule has to be polar in order for it to do hydrogen bonding, but it also has to have a hydrogen bonded to an FON. So this can do hydrogen bond, it can do dipole-dipole, and it can do London force. So it does all three. Lots of intermolecular forces. What about this guy? Can this do hydrogen bonds? No. It does not have a hydrogen bonded to an FON. So no hydrogen bonds here, but it is polar because you got these lone pairs here. So it will do dipole-dipole, and it will do London force. So what was the question? Which one's got a higher vapor pressure? That means it can become a vapor easier. This guy, higher vapor pressure. Okay? Higher vapor pressure, lower boiling point. All right? This one's going to have a higher boiling point, a lower vapor pressure, high surface tension, high viscosity. Okay? Everybody clear on that? Okay, and then the last thing I want to do is just throw in a question that you will sometimes see on an exam. Okay, so we have these three organic molecules, right? This happens to be ethanol, this is 1-propanol, and this is ethyl methyl ether. Again, you don't need to name them. You're not in an organic chemistry class. But what I want you to do is take a look at them and see Which one can do hydrogen bonding? Remember what I told you guys, the hydrogen to the right of the oxygen? So this can do hydrogen bonding. And if it can do hydrogen bonding, it can also do dipole-dipole and obviously London force. Okay? This one can also do hydrogen bonding, dipole-dipole, London force. Okay? This one can't do hydrogen bondings because there's no H to the right of the oxygen. But, you know, it's got lone pairs here, so it'll be doing dipole-dipole London force. All right, so what if the question was, which one has the highest boiling point? Well, these two guys have the exact same intermolecular forces. But you remember what I told you guys about London forces? That the bigger the molecule, the more the surface area, the more the London forces. Okay, so even though these two can do the exact same thing, this is a bigger molecule, bigger molecular weight, bigger London forces. So this is going to have the most intermolecular forces. So we're going to write this as number 1. This is going to have the highest boiling point. Then this is going to be second. And this is going to be third. So we can put them that way, or just like this greater than this, and this is greater than that. Okay, good. I think we are all set with chapter 11. Very good. Next, we move on to 12.